In this video, we're going to be talking about average rates of change. And then before we do that, we need to review what we mean by slope. It's a very common concept that you've done in nearly every math class for the past 2 to 3 years. So slope, again, is the measure of rise over run. If we're given 2 points, we can just say slope is equal to the rise of the line divided by the run of the line. So take any 2 points, like here, slope is 3/4. If it's uphill slope, it's a positive. If it's downhill slope, it's negative. So here, your slope is 3/4. Here you have a negative slope, so my slope is equal to a negative. Take any 2 points on the line and find your rise and run. How far do you go down and how far do you go over? That's going to be 1, 2, 3, 4, 5, 6, 7, 8 boxes. And you go over 4 boxes, which is -2, is my slope here, which means I could have actually just used these ones, these points, and done 2 and 1 and got the exact same answer. Here, if I have a horizontal line, the slope of a horizontal line will always be 0. The reason for that, your rise here is 0 and your run is, I believe, 8. So 0 divided by anything, it wouldn't matter what that run is, it's going to be 0 anyway because it has no rise. Now, if you're given 2 points, there is a formula for slope. It is the second y minus the first y over the second x minus the first x. Y minus y over x minus x. Sometimes you see this formula written as the change in y over the change in x, or how much does y change versus how much does x change. And this is kind of how it applies to today. So you're doing the second y minus the first y, -7 minus 3 over -5 minus -9. Minus minus changed it to a plus. That'd be a -10 over -5 and 9. It would be 4. Always reduce it. This would be a downhill slope because it's negative, and it rises 5 and runs 2. Again, slope is equal to the second y minus the first y over the second x minus the first x. Minus minus changed to plus. -4 and 1 is -3. -7 and -2 is a -9. A negative divided by a negative is a positive, and let's reduce it. That's an uphill line with a rise of 1, run of 3. Slope on the last one, y minus y would be 3 minus -5 over -1 minus -13. Minus minuses are both pluses. That'd be 8 over 12, so it's an uphill line because it's positive. Reduce it by 4 gives you a 2 and a 3, so this will be a 2/3 slope. Now let's connect that to our new lesson. Today we're going to be talking about average rates of change. It says for functions, the slope is constant between each pair of points. For linear functions, actually. So it actually left that word out right there. Let's write in for linear functions, the slope is constant. What that means is if you've got a linear function, it doesn't matter if you pick here and here, your slope is the same as if you pick down here and up here. Okay, that slope never changes if it's a linear function. However, for nonlinear functions, the slope changes between pairs of points. Because of this, we find average rates of change. And it says average rate of change of a function between 2 points is the slope of the line that passes through it. What we're doing with the average rate of change, we're asking ourselves, how much does y change in comparison to how much x changes? Like looking over here at this set of points. From this point to this point that are both on the graph, how much did y change? In comparison to how much did x change? Now, how do we find that? We find that with our slope formula. It's the same thing. This is called a secant line. A secant line is any line that passes through a graph at 2 different points. So since we cross here and we cross down here, this line that we're talking about is a secant line. Again, the slope of a secant line tells us how much these y values and x values change. Because when we find slope, we find out how much y changed from here to here and how much x changed from here to here. And that y compared to our x is, again, the slope of a secant line. The formula for an average rate of change of a function on the interval from a to b, again, the slope of a secant line, I'm going to put SEC down there because we're talking about a slope of a secant line now, will simply equal, okay, we're looking for a slope from a to b, like on this graph over here. We're going to do y2, which is f of b, minus y1, which is f of a. So how do we find our y's if we're only given x values? We plug them in. We plug the x values in. So f of b minus f of a over b minus a. It's the exact same formula. It just says take this value and this value, plug them in to find the y values. Then we're going to find y2 minus y1 over x2 minus x1 for those points. Okay, let's try that on an example. It says, given the function graph below, find the average rate of change. How much does the function change from -2 on this first one, from the x value of -2 to an x value of +1? Well, let's find those 2 points on my graph. An x value of -2 is located here, so the point on my graph is right here. To an x value of 1. Okay, 1 on my graph. Here's 1 on the x-axis, so on my graph, there is my y value. So therefore, we've got to, first off, we need some y values. So what you can do is you can take these two x values, because that's what they're giving you. They're giving you an interval from this x to this x, and find the y values associated. When x is -2, y is 1. When y is 1, or excuse me, when x is 1, y is 1, 2, 3, 4, 5, 6, 7, -8. There's the two values. So we're simply finding the slope of the line that connects those 2 points. We're finding the slope of this secant line. So you got y2 minus y1. So the slope of the secant is y2 minus y1 over x2 minus x1, which is -2. Minus minus is a plus. That's -9 over 3, which is a -3. And I'm going to leave it over 1 for just a second. It's so that I can hopefully explain to you one more time what we're actually doing here. Okay, so I've actually drawn the secant line here, and here's the 2 points on your graph. And let me try to explain again what you just found. -3 was a slope. That means from this point and this point that are on your graph. Okay, your graph changed from that point to that point for an average of this. Now, did your graph actually go down 3 and over 1? No, right there is my graph. Okay, but the secant line went down 3 and over 1. Now, did my graph go down 3 and over 1 again? No. But what is said from this dot to this dot that was on your graph? Overall, the graph went down 9 and it went over 3, okay, between the two dots. So on average, from this interval from here over to here, that graph went down 9. And the interval was of a length 3. So therefore, since the graph went down 9 and the distance between the x values was 3, on average, the graph changed. It went down about 3 y's for every 1 x that it went over. So that's what your average rate of change is. And again, we can see that right here with these 2 points. It didn't go exactly down 3 and over 1 at every point, but it did on average. Okay, number 8, let's do it again. So the interval is from 0 to 4. So the first thing we have to do is find those two values on our graph. When x is 0, here's my y value. When x is 4, 1, 2, 3, 4, here actually it's here's my y value. So we're simply saying from that dot to that dot, how much does your graph change? Okay, so we're finding the slope of a secant line. So we need the y values that go along with it. So when x is 0, my y value is 1, 2, 3, 4, 5, 6, 7, -7. I can just write it above it. When my x value is 4, my y value is 1. So we're going to do our y2 minus y1 over x2 minus x1. Minus minus is plus, so that's 8 over 4, which is 2, or 2 over 1. So from this dot to this dot, on average, for every 2 that we go up 1 over, or we go over 1. Now, obviously, from here to here, that's not what happened. But if you continue going up 2 and over 1, up 2 and over 1, you actually go from this dot to this dot. So on average, we went down, then we came up some and all this. But on average, from here to here, the average change was 2 for every 2 that your y's went up. Your x's would have went over 1. Now on number 9, it says find the average rate of change given the function on the given interval. And anytime you're given an interval, that's from this x value to this x value. Round your answers to the nearest hundredth as necessary. Now here, we're doing the exact same thing, except for we're going to have to find our y's a different way. Again, the slope is equal to y2 minus y1. Well, how do we find y2 and y1? If we're given x2 and x1, we plug it in. So the first thing we need to do is find what is f of 2. That'll be your y2, and then we're going to find f of -1, and that would be your y1. So plugging these x values in, let me write this down. Negative 2 squared plus 6 times 2 minus 14. Then we're going to do negative 1 squared plus 6 times negative 1 minus 14. And I write this down. I want to work it out just to remind you on this one thing. When you square this, make sure that since this is negative x squared that you square the 2 first and then you put the negative in front of it. Here you're going to square the negative 1 first and then you're going to put the negative 1 in front of it. So that gives you, that'd be negative, and then 2 squared would be 4, plus 6 times 2 is 12 minus 14. That would give you negative 18, and 12 is negative 6. Doing it here, that'd be a negative 1 squared would be 1, so that'd be a negative 1. A 6 times negative 1 is a negative 6 minus 14. And the final answer that would be negative 21. So now let's find our slope. Slope is equal to, now we got to be careful about which one's x2 and y2. Your 2 is your second x, so therefore your negative 6 right here, that would be your second y, and this would be your first y. So we're going to do negative 6 minus negative 21 over 2 minus negative 1. Minus minuses make a plus. Negative 6 and 21 is 15 over 3, so that's a rise and run of 5 and 1. Number 10, doing the same thing. First step, you've got to find f of negative 7 and f of negative 9 to find the y values that go along with these two x values. And I've done that for you there. So therefore, our slope would simply be y2 minus y1. And let's see, we'll let this be our y2 and x2, and this be our x1 and y1. So y2 minus y1, those are our two y values that we got when we plugged in the x's, over x2 minus x1. Minus minus makes a plus. That gives me a negative 8 over negative 7 and 9 is 2. So that'd be a slope of negative 4. And again, if you need a rise and run, what that means from this point to this point, for every 4 that your graph goes down, it goes over 1. On average, not because again, it's not linear, so therefore that slope is not constant. That is an average slope. Next step, again, gives you an x and a y. So we'll do it like this just to show it this time. We've got to plug in 4 to get a y value. We've got to plug in 7 to get a y value. That would give you a 183 when you plug in 7 and a negative 3 when you plug in 4. That would be your y values. So again, simply your slope is equal to y2 minus y1 over x2 minus x1. Minus minus is plus. That'd be 186 over 3, which is a slope of 61. So that's a very steep portion of a graph is what that tells you. Next one, I'll show you the steps as we plug it in. We need a y value that goes with 5, and we need a y value that goes with negative 2. So let's plug in the 5. That'd be negative 5 to the 4th. Make sure you do 5 to the 4th first. Plus 3 times 5 to the 2nd, minus 17. Negative stays, 5 to the 4th would be 625. Plus, I'm going to do this whole term, that's 3 times 25, which is 75, minus 17. When you clean that up, you get negative 567. Then you find f of negative 2, which is going to be negative 2 to the 4th, plus 3 times negative 2 to the 2nd, minus 17. Put your equal sign there, which is going to equal, oh no, that was a negative. My bad. I left my equal sign off, so put your equal sign here. F of negative 2 equals. Leave the negative. Negative 2 to the 4th would be a positive 16. Make sure you don't do this first. Raise it to the 4th, then put the negative. We're going to square it. That's negative 2 times negative 2 is 4, and then multiply by 3 would be 12, minus 17. When you simplify that out, you get a negative 21. So again, if you want to write the slope in the other form that I gave you, it's f of b minus f of a, which would be f of 5 minus f of negative 2, which is the same thing as y2 minus y1 over x2 minus x1. So that's going to be f of 5, which we found was negative 567, minus f of negative 2, which is a negative 21, over Minus minus makes a plus, but I'll leave it for now as 5 minus negative 2. Both these minus minuses are pluses. And now I have a final answer of, that's a negative 546 over 7, which gives you a negative 78. Number 13. Any of the methods that I've showed you is fine. If you just want to say these are your x1 and x2, and you could say, okay, my y1 and y2, and you could even put it like this. Whatever notation you want to do, it doesn't matter. So when you plug in 2, you're going to get negative 1, and that would be your y1. When you plug in 8, 8 minus 4 is 4 over 8. That's going to be 1/2, and that would be your y2. So now your slope is y2 minus y1 over x2 minus x1. Minus minus makes a plus. Common denominator here, I'm going to change 1 to 1 over 1. Multiply top and bottom by 2 gives you 2 over 2. So you now have 3 over 2 over 6. This is called a complex fraction. To actually divide this, put this over 1. To divide two fractions, flip the second one and multiply. Let's cross cancel, leave that as a 1 and that as a 2. So your slope here is going to be 1/4. And finally, number 14, I believe this one might be a little bit tougher. Let's see, when you plug in negative 1, you get the square root of negative 1 plus 5. That's the square root of 4, which is 2. When you plug in 7, you get something a little bit nastier. You get the square root of 12. And let's go ahead and change that to a decimal form. That's about 3.46. Round to the nearest hundredth, and I believe in the directions it said to round to the nearest hundredth if necessary, so let's go from there. So a couple of ways we can write our slope here. The slope is equal to y2 minus y1. So here's your y value, so that's going to be, we could write it as root 12. Actually, let's simplify that to be 2 root 3 minus 2 over x2 minus x1, so it'd be plus. So we could either write our answer as exact as 2 root 3 minus 2 over 8, and we could split that and do all sorts of things. So that's an exact answer. Or if we want the decimal approximation, that'd be 3.46 minus 2 over the same 8, 7 minus negative 1, which is going to be about 1.46 over 8, which is going to be approximately somewhere around 0.18 would be your slope. Now, anytime you're given slope as a decimal approximation, I just want to remind you that decimals can always be changed to fractions because it's confusing because you're used to slope as rise over run. So that's 18 hundredths. That is a decimal. That's tenths hundredths. So 18 hundredths written as a fraction could be 18 hundredths, which could be reduced to like 9/50ths. So you still, if you want to write it like that, would have a rise and a run. Okay, the next one we have some application problems. It says a company's total cost in dollars to manufacture X units is given by this. So here's our cost, and we're manufacturing this many units. Find the average rate of change for the total cost for the first 200 units manufactured. So when we're saying the first 200 units manufactured, our X values there, the first 200 would be going from 0 manufactured to 200 manufactured. And we're wanting to know what kind of rate of change, the cost. How much does it go up in those first 200 units? Well, first off, we need some Y values. The way we're going to find those Y values, again, we're going to find C of 0. We're going to plug in a 0 here, here, and it's obvious that we're going to get 1200 because this goes to 0 and 0. Then we're going to plug in and we're going to find C of 200. We're going to find the Y value associated with 200 now, and we get 11,200. Let me take a decimal out, that comma makes it look a little confusing. So that's how much my cost goes up. For producing 0, my cost is 1,200. If I produce 200, then my cost has gone up to 11,200. So how much did that change? Is all that's what average rate of change is. So it makes more sense when we look at it in terms of an application. So my slope of my secant line, if this were actually graphed, would be y2, 11,200 minus y1, which is 1,200, over x2 minus x1, 11,200 minus 1,200 is equal to 10,000 over 200, which is equal to 50. $50. Now let's write that as a fraction. So we can write that as $50 because this was in dollars and the bottom was in units that we produced. So now let's try to make sense of that. On average, for every extra unit that we're producing for our first 200, we're paying an extra $50 per unit to build those. Now, is that a linear change? No. So we might be paying maybe 60 per unit for the first few, and then 40 a unit, and then it changes because the cost is not a linear change. Okay, next up it says a ball is thrown straight upward. Here's the height of the ball after t seconds. Find the average rate of change in the height of the ball from when it reaches its maximum height until it reaches the ground. Now this is going to be a little tougher because this height, notice that it's parabolic. If you were to graph this negative 16t squared, you're going to get something that looks like this. Now you can either graph this, or if you remember from previous classes, anytime you have a projectile motion like this, a quadratic equation, this is called the vertex. And I think I told you in a problem last chapter, we can use negative b over 2a to find this maximum height, or we can use a graph. Regardless of which way you do it, let's see, this is my a and my b value. That'd be negative 80 over 2 times negative 16 is negative 32. When you divide that, you're going to get 2.5. So my maximum height occurs, my vertex here occurs after 2.5 seconds. So we want to know, let's see, find the average rate of change in the height of the ball from when it reaches its maximum height, and it reaches its maximum height at 2.5 seconds, up until it reaches the ground. Now we got to figure out when it reaches the ground. Now it reaches the ground right here when my height is equal to 0. So now we've got to take our function, negative 16t squared plus 80t, and we've got to find out when is it going to hit the ground. When is h equal to 0? We can solve that by factoring. Factor out a negative 16t. You're left with t minus 5. Set each of these equal to 0, and you get t as 0, and you get t as 5. So it's on the ground at time 0 and at time 5. Okay, that makes sense because it was at its maximum height at 2.5. So wouldn't that be the same after 2.5? It would take double that amount of time for it to hit the ground since it was launched from the ground? Sure. So we're looking for what's the rate of change from 2.5 to 5 when my time is 2.5 to my time is 5. Now that's my times. Now I need my y values, or in this case, my h values. And to find those h values, all I'm doing is I'm going to plug in 2.5 here, and I'm going to plug in 5 here. And that's going to tell me what my heights are at those two instances. And when I plug those values in, I get actually 100 feet at time 2.5 and 0 feet, which you remember at 5 seconds we were on the ground, so that makes sense. So there's our x values and our y values. So to find our rate of change, we're going to do y2 minus y1, which will be 0 minus 100 over x2 minus x1, and that gives me negative 100 over 2.5, which is equal to negative 40. And if you want to do this, this was in feet, and our time was in seconds. So what does that mean? That means on average, the ball here is decreasing on average over this interval 40 feet every second. So if you want to get to the physics side of it, we've actually just found an average acceleration or an average velocity over this interval, not acceleration. But how quickly is my ball falling over that interval?